Welcome again. Today we want to see how the total travel time equation can be helpful to extract important parameters to start the specific layer below the ground. The equation, if you remember, is given as t squared is equal to x over v squared plus 2h over v squared. How can this formula help us? Well, if you draw the graph of t against x within the x-axis, we find that if this is the vertical line represents the time, the total travel time, and the horizontal axis represents the distance of the source to the geophone, let's say x. If you draw this graph, it will be curved. Of course, it has the structure of the quadratic equation. And if you draw the t against x, the graph will be curved and it will be having the intercept to hv. If you draw the graph, it will look curved this way. Assume we consider only the direction of positive x, and it will be curved in this way. And the point of intersection will be 2h over v. Of course, what does 2h over v mean? 2h over v, if you remember from our diagram, if you have, okay, let's leave this old diagram. Let's use this simple one. I want to make you remind you that 2h over v, what does it mean? 2h over v directly mean, because h was the thickness of the layer, if the h is the thickness of the layer, then 2h over velocity mean that 2h is the total of the vertical distance covered on traveling of the seismic waves from the surface to the interface here downward and then back again. H and H, you get 2h v. So 2h over velocity, 2h over velocity, 2h over v, I mean, will be equals to the two-way vertical travel time. Let's call it t naught. And therefore, let's return back to our equation. This equation here can be rewritten as t squared is equal to x over v squared plus t naught squared. So from this equation here, which is exactly the same as this, we can draw the graph of the equation, and the intercept can be given as t naught, because t naught is 2h over v. So this is 2, of course, t naught. So direct from this graph, the intercept of this graph will help us to get the thickness of the layer, because t naught will be compared to this one intercept, and then you can extract the important parameter h. But how can we get the velocity of the equation, the velocity of the layer described by this equation? Well, there is a method known as the Green method. Green method. This is the important method. It helps us, instead of drawing the curved graph, it helps us to convert this curved graph into the linear straight line. What does it mean? What does Green method mean? Meaning plotting of t squared against x squared. If the total travel time equation is drawn in a graph, but in form of t squared against x squared, of course we will get the straight line. So from this straight line, the slope of this line will help us to extract the velocity of the layer. If you remember, and I showed you how you can memorize this formula, that t squared is equal to x over v squared plus 2h over v squared. So if you draw the graph of t squared against the x squared, you will see that the slope is 1 over v, and then plus the intercept to h over v squared. So this will be the slope of the graph. And if, for example, the slope of the graph is obtained to get the value m, then it will be compared to 1 over v squared. And therefore, this will imply that the velocity will be the same as the square root of the reciprocal of the slope. And therefore, from this graph, you will extract the velocity of the layer, and you get the thickness of the layer. Of course, this is the intercept of, also gives the thickness of the layer. You will get know the thickness of the layer and the velocity of the layer. That is enough to describe the layer where we study by using seismic method. Thank you for following this series. Just subscribe if you are new. Subscribe this channel so that we can work together as a family. Thanks.